So the first batch of questions all had to do with this drawing. Okay? And the questions were things like, what is the image of C under this transformation? This is a translation that goes from xy to x plus 4 and y minus 2. So point C is this one right here. And if you go 4 to the right and 2 down, 1, 2, 3, 4, 1, 2, you wind up at E. And if you had put the coordinates instead, that was okay too. Then what rule describes the translation from F to B? This is how we write rules of translations, right? Like this. This is how your book does it. You can also do it this way, which is a mapping, which says every point xy in the pre-image maps to x plus 4 and y minus 2. But that means that F to B, here's F. How does it get to B? It goes 2 to the left and 1, 2, 3, 4 up. So it is negative 2 comma 4. What's the image of C under that? XY mapping to x minus 2, y minus 4. Well, it's G. Let's see why. Here is C. X minus 2 is 1, 2. Minus 4 is 1, 2, 3, 4. That's the point. And if you had given me the coordinates, that was okay too. And then what maps B to A? Here's B, here's A. So it's just 1, 2, 3, 4, 5, 6, 7, 8 spaces to the left and 0 spaces up or down. So that means what rule describes the translation B to A? And that's what the rule looks like. What's the image of H under x comma y? X minus 2 to y plus 4. So here's H. Where's H? Here's H. X minus 2 would be 1, 2, and plus 4 would be 1, 2, 3, 4. H maps to C. And if you had used the coordinates instead, that was fine, negative 2 comma 2. Okay. And then the translation asked for D to H. This is from D to H. It's 1, 2, 3, 4 to the right, and 1, 2 down. And that looks like this. If you are translating and you're given a map instruction, like a mapping like this, or even like this, really what you're being asked to do is take these coordinates and plug them in here to get the new coordinates. So if P is your pre-image, and it's negative 9 comma negative 4, to get the image, you plug negative 9 in here, get negative 15, plug in negative 4 here, and get negative 11, and that is your image. If you're looking for the image of Q, you take these two coordinates, plug them into your mapping. Negative 5 minus 6 is negative 11. 1 minus 7 is negative 6. That's your answer. 2 comma 8, plug it in here, you get negative 4 comma 1. Everybody had this question. Triangle has its vertices at A, negative 3, negative 1, B, negative 2, 2, and C, negative 1, negative 2. This is the kind of thing you really can do pretty much only if you draw a picture. Okay. I'm going to do this the physical way here. I'm going to say, here's my triangle, and I'm going to take A, which is negative 3, no, what is it? Negative 3 comma negative 1. I'm going to put it here. B is supposed to be at negative 2, positive 2, which is here. And then C is supposed to be over here at negative 1, negative 2. So that's where it starts out. And then the question was, if the triangle winds up with its vertices at 1 comma 1, which would be here, and 2 comma 5, which would be 2 comma 1, 2, 3, 4, 5, where is the third vertex? Well, Transformations in isometry. Could go like this. Right. Not as easy. If somebody had given me negative 1/2 comma 3, I would have taken it, right? But how about if we did this? Yeah.
I don't understand how we would have done this because when we're taking the test, we don't really have that little triangle.
No. You can draw pictures. You can try to envision it. The idea here is, can you envision this? Can you picture this in your head? If you can, that's great. If you can't, then you can draw a picture. If you can't do that, then we need to talk about it. This is not a question, understand that this is not a question that is going to separate people who passed the test from people who failed the test. Okay, not every question on the test works that way, right? There are going to be some people who can do this and some people who can't. And that's sort of how you figure out who gets A's, who gets B's, who gets C's. But if you couldn't do this and you could do everything else, that's okay.
Yeah, I know, but I still want to understand how to do it. Like, how would you do it without the triangle? Like, is there like a formula? Or...
No, there's no formula. The fact that you keep asking me for formulas, that's sort of the problem. It's a thinking question. Triangle has vertices at -3, 1, 2, 3, -1. So here's one vertex. Okay, that's A. -2, comma 2 is here. That's B. Okay, and -1, comma -2 is here. That's C. And this is the triangle, the original triangle. Okay. Then it says we're going to move this. So where are we going to move it to? Well, one of the vertices is going to be here, and the other one is going to be 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Yeah, here. Okay. Now, which side of this triangle moves 1 left or right and 4 up or down? Because that's the one that's going to fit here, right? I'm asking the question.
C.
C is a point, but which side? Which one? BC. So BC could go here, right? Well, all right. Now, this way it's tilted like this, right? Okay. Here it's tilted like this. Well, if I tilted it this way, I shouldn't have put BC here. Right? I don't know which one goes where. Right? I could put B or C here. And that's why I did this, so that it would be easier to actually look at. You can do it like this, in which case this side here goes this way, and this side here goes this way. Oops, do this right.
But,
Yeah.
I'm asking how to do it without that triangle.
Well, I don't know that I don't know that you can do it. Oh, you mean without this piece of paper?
Yeah, I know, but
Right.
I don't know.
It's a puzzle. That's all it is. It's a puzzle. Okay? If I take this and I swing this around, right? This point goes up here. This point goes down here. So that means now it's sort of like this. So how do I get from C to B? I went 1, 2, 3, 4, and 1 over. Oh yeah, C to B. 1, 2, 3, 4, and 1 over. Okay, got that. How do you get from C to A? You go 2 to the right and 1 down. So there it is. 2 to the right, 1, 2, and 1 down. There's A. And does that work out? How do I get from A to B? 1, 2, 3, and 1 over. 1, 2, whoops, 1, right, hang on. Right, 1, 2, 3, and 1 over. Does that work?
Yes. What's the answer?
Well, I had the answer is 3, 2.
Okay.
3, 2. Okay? So that doesn't work. So maybe that's not it. So then let's see. Maybe this is B. Maybe this is C. So how does that work out? Oh my gosh, it must have been a reflection. 1, 2, 3, 4, and 1 over. 1, 2, 3, 4, and 1 over. Okay. So it goes up 4 and 1 to the right instead of up 4 and 1 to the left. So now if I'm continuing in the same direction, I'm going to go down 3 and 1 over. 1, 2, 3, and 1 over. Like that. Does that then work? Does this fit? 1, 2, and 1 down. 1, 2, and 1 down. Yes. And it's a puzzle. And that's the answer to it. And, you know, if you got it, great. And if you didn't, that's okay too. And the more you try, the more you'll be able to do them. That's really what it comes down to. Okay? That was actually probably the trickiest problem in the whole batch. No, I mean, you're perfectly right to be asking me, how do I do this? And the thing is, sometimes it's trial and error. Sometimes it's visualization. Some people are just so good at this, they look at the picture and they immediately go like that. They know. Or they don't know, they don't draw a picture and they can do it in their heads. I'm not one of those, as you just saw. Right? I've got to flip it around, take a look. And that's okay. So the original one here was 3, 2, which is here. 1, 4, which is here. And -3, -5, which is 1, 2, 3, 1, 2, 3, 4, 5. So this was the original triangle. And this says find the line y is equal to x. That would be this line right here. And then reflect across that line. So how do you do that? Well, here's point S. If it looks into this line right here at a 90-degree angle, it's half a diagonal space away. So half a diagonal space on the other side is where S prime is going to wind up. With you looking down this way, 1 1/2, 1 1/2. So actually, that's where it goes. That's U prime. Okay. That's that. And then here's B prime, which is 1, 2, 3, 4, 5. 1, 2, 3. Okay, now how did I get that? B looks in the mirror here, 1 diagonal space away, goes to here, 1 diagonal space away. So once again, it's like I'm not looking to, to nick somebody for, a little mistake in the drawing. But what I'm looking at here is, do you see the reflection? Do you see that this is the line of reflection, that this point is reflected in this line here because these distances right here are equal? And do you see here that this distance is equal to this distance? And that's how you figure out where the reflection is. Yeah. So let's see if I got this one right. It's S of 6, 1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1. U was 2, 5, 1, 2, 1, 2, 3, 4, 5. And B was -1, 2. So it's this and then that. So this ink drawing here was the original. And again, it was reflecting across y is equal to x. So that's this line right here. If B is looking into the mirror, it sees 1 1/2 spaces and then 1 1/2 again on diagonally, right? And here, U goes 1 1/2 and then 1/2 and 1 more over here. And if S is looking into the mirror, it's looking across the same line that you did, but it's going 1, 2 1/2. So There's your half, and 1, 2 more is up here, and that's what it should look like. Okay, this one actually did say, Amir, this one did say, right, x is equal, y is equal to negative x. So the line went this way. Okay? And if you're saying to yourself, well, how am I supposed to know that? Well, if x is 1, y is negative 1. If x is 2, y is negative 2. That's what it means. Right? So here are the points where negative 6, comma 1, negative 2, comma 5, and 1, comma 2. So right here, from here to here, here to here, and here to here, was the original triangle. And this was the line. So here's a space and a half diagonally, and a space and a half diagonally this way. So when B looks into the mirror, this is where B's reflection is. When U looks into the mirror, it's 1.5 spaces in this way, so 1.5 spaces over here is where the reflection is. Here it's 1, 2.5. So there's the other half, and it's 1, 2. It's up here. And that's what the drawing should look like.